Today we're going to be looking at your nitrogen cycle. So naturally, your nitrogen exists as your N2 gas. N2 gas cannot directly be used by your different organisms. So there are different processes or different steps that involve breaking down N2 into other forms of nitrogen. In nitrogen fixation is essentially the process that converts your N2 gas to ammonia, your NH3. This can be done via nitrogen fixing bacteria, or it can be done utilizing your lightning. Because your N2 is extremely stable, the next step that we're going to be looking at is just above this, and this is your ammonification. So this is a process where we are converting your nitrogenous waste from your living animals or from the remains of your dead animals and plants into ammonia. But when it occurs in soil, as it is doing right here, you're going to end up forming your ammonium or your NH4+. Next, your NH3 from your nitrogen fixing bacteria is converted into your NO2 or your nitrates, right? And this is done by soil bacteria. We have your assimilation. Just your plants are taking up the form of nitrogen through their roots. Final step is your denitrification process, and this is essentially the reduction of your nitrate into your gaseous N2 by anaerobic bacteria. In your first initial image, you saw the natural process of nitrogen fixation bacteria. You also had your lightning, where it strikes and breaks apart the bond in your N2. In addition to this, you have your industrial processes like your Haber process. You have the combustion of engines, and you also have high temperature furnaces. For the methods that release nitrogen into the environment, we saw a denitrification process, and this was converting your NO3 or nitrates back into that gaseous atmospheric nitrogen. You also have ammonium oxidation. This entire nitrogen cycle, we end up with three main types of oxides of nitrogen in the atmosphere. So nitrous oxide is of great concern as it can produce your nitrogen and your oxygen radicals. And as we saw in your earlier slides, the nitrogen oxides can produce these radicals and therefore decrease the concentration of your ozone layer and cause acid rain. Rain is considered acid rain when the pH falls below 5, because naturally rain is actually slightly acidic because of the concentration of your carbon dioxide in the environment. So your acid rain is caused by your sulfur dioxide and your nitrogen dioxide in the atmosphere. So we're looking at the formation of your acid rain, and in this entire process we have your one of the largest and main sources of your sulfur dioxide gas, and that is the emission from your coal factories, right? We also have your nitrous oxides, and these are coming from your vehicular emissions along with some of your industrial power plant emissions. And your SO2 can also come from your volcanic eruptions. So in the first process, we have the oxidation of your sulfur dioxide, your SO2. This reacts with your oxygen to give you a sulfur trioxide. Once the sulfur trioxide comes in contact with water vapor, you end up with your sulfuric acid. In terms of your nitrous oxide, these are essentially reacting with your hydroxyl radicals. Radical reacts with your nitrous oxides and give you a nitric acid. Looking at your wet versus your dry deposition. So in your wet deposition, your sulfuric and your nitric acids dissolve in cloud droplets and fall as rain, snow, sleet, or fog. So this directly delivers acids to your soils, your water bodies, and your surfaces. Versus your dry deposition occurs when your acidic gases and particles settle onto surfaces without precipitation. So these compounds can later be washed off by rain, creating your acidic runoff. So your acid rain has many effects, such as the damage to your roots, the leaves of trees, soil acidification, erosion of limestone structures, and so on and so forth. So now we're going to be looking at your atmospheric pollutants. So your pollutants can be split into your primary and the secondary pollutants. So for your primary pollutants, these are emitted directly from your source or directly from a process. And in the case of a secondary pollutant, this is not directly emitted as such. So it's not coming directly from the source, but it's formed when other pollutants react in the atmosphere. So one of the pollutants that we're highlighting now is from your hydrocarbon fuels. So this is looking at your carbon monoxide and your soot, and this is your incomplete combustion. It is important to note that leaded petrol has been globally phased out since 2021, but we still have lead pollutants that are present within our atmosphere that we have to decrease. Now we're going to be looking at the formation of photochemical smog, which is seen in this image here. So this smog is formed when your sunlight drives chemical reactions between your primary pollutants from automobiles and normal atmospheric compounds. So this product, or your smog, is essentially a mix of 100 different chemicals, with the most abundant being our ground level ozone. So for this entire topic, we've been looking at your atmosphere and the different atmospheric pollutants and effect on our environment and our human health. So obviously we have to mention on preventing your atmospheric pollution. So in your module 1, you would have done your biodiesel assignment. So hopefully you're somewhat familiar with these alternative fuels to our fossil fuels. We can decrease the amount of vehicle emission by carpooling, using public transport, walking, which is also known as your P2, of course, reforestation of our trees. Lastly, we are highlighting controlling atmospheric pollution. So under this, you have the use of your catalytic converters in your vehicles, removal of your volatile organic compounds and hydrocarbons via adsorption, such as your activated charcoal, and so on and so forth, in order for us to have a better and healthier environment